This is SpaceTime Series 25, Episode 72. Coming up on SpaceTime, a close encounter with the planet Mercury. NASA's Parker Solar Probe flying to within 8.5 million kilometres of the Sun. And work begins on a new European tracking station dish in Western Australia. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
The BepiColombo spacecraft has just undertaken its second close flyby of the planet Mercury. Like its first encounter last year, the probe swooped down to within 200 kilometres of the heavily cratered and rocky planet's surface. The joint European and Japanese mission is undertaking 6 gravity-assist braking manoeuvres needed to slow down the spacecraft enough to eventually enter orbit around Mercury in 2025. The primary purpose of this flyby was to use the planet's gravity as a brake in order to help fine-tune BepiColombo's trajectory. Having been launched aboard an Ariane 5 rocket from Europe's Kourou spaceport in French Guiana back in 2018, BepiColombo has been making use of 9 planetary flybys, 1 of the Earth, 2 of Venus, and 6 of Mercury, together with the spacecraft's solar electric propulsion system, to help it achieve Mercury orbit insertion against the enormous gravitational pull of the Sun. Even though BepiColombo is still stacked in its cruise configuration for these flybys, meaning many instruments can't be fully operated, mission managers were able to undertake a limited number of scientific observations of the rock nearest the Sun. The sequence of images were undertaken by BepiColombo's 3 monitoring cameras, showing the planet's surface, while a number of magnetic, plasma and particle monitoring instruments sampled the environment for the hours around closest approach. The sequence of images were taken by BepiColombo's 3 monitoring cameras. They showed the planet's surface, while at the same time, a number of magnetic, plasma and particle monitoring instruments were able to sample the environment in the 2 hours around closest approach. A unique aspect of the BepiColombo mission is its dual spacecraft nature. There's the ESA-led Mercury Planetary Orbiter and the JAXA-led Mercury Magnetospheric Orbiter, both of which are being delivered into complementary orbits around the planet by a third module, ESA's Mercury Transfer Module, basically the cruise stage of the mission. Working together, they'll study all aspects of this mysterious inner planet, from its core through to its surface processes, its magnetic field and its exosphere, in order to better understand Mercury's origin and evolution. Dual observations are key to understanding solar wind-driven magnetospheric processes. And BepiColombo will break new ground by providing unparalleled observations at 2 different locations at the same time of the planet's magnetic field and its interaction with the solar wind, the stream of charged particles constantly flowing out of the Sun. During these flybys, it's not possible to undertake high-resolution imagery with the main science camera because it's shielded by the transfer module while the spacecraft is in cruise configuration. However, BepiColombo's 3 monitoring cameras are taking photos. Because BepiColombo's closest approach was on the planet's night side, the first images in which Mercury will be illuminated were taken around 5 minutes after closest approach, at a distance of around 800 kilometres. The cameras provided spectacular black and white snapshots in 124 by 124 pixel resolution. Their position on the Mercury Transfer Module so that they can also capture the spacecraft's solar arrays and antennas. As the spacecraft changed its orientation during the flyby, Mercury was seen passing behind the spacecraft's structural elements. This report from ESA TV.
A collaboration between ESA and the Japanese space agency JAXA, BepiColombo consists of 2 scientific orbiters, a transfer module to propel them to Mercury, and a sunshield. Protected by hand-stitched ceramic thermal blankets, the entire spacecraft is 6.5 metres high and will only just fit inside the fairing of its Ariane 5 launcher. Designed to withstand temperatures of up to 450 degrees Celsius, BepiColombo is one of the most technically and scientifically complex missions ever launched.
80% of our material needs to re-qualify for this mission because we hadn't tested before in that harsh environment. So it's a real challenge to go there and to bring 2 spacecraft in an orbit around Mercury.
The first challenge is getting to Mercury. Flying directly isn't an option. The sun's gravity means any spacecraft would be going too fast to make it into orbit. Instead, BepiColombo will take 7 years to reach its destination, combining solar electric propulsion with a total of 9 flybys of Earth, Venus and Mercury.
When we fly, we constantly brake against the sun because we fly into the inner side of our solar system. Yeah, and when you fly towards the most heaviest element there, you constantly accelerate. We don't want that. This is why we decelerate.
Once they arrive at Mercury in late 2025, the orbiters will separate from the transfer module to begin their comprehensive scientific mission in 2026. With its 11 instruments, ESA's Mercury Planetary Orbiter will study the surface and internal composition of the planet. Meanwhile, JAXA's Mercury Magnetospheric Orbiter's 5 instruments will study the planet's magnetic field. Together, the orbiters will not only reveal more about Mercury, but also the history of the inner solar system.
Because Mercury is not tilted like Earth, it's spinning almost in the orbital plane. Therefore, there are some craters on the poles which never see sunlight. And in these craters, we found water ice. And this water ice could be stable over millions and billions of years. And that's a fantastic thing also about Mercury.
This is SpaceTime. Still to come, NASA's Parker Solar Probe completes its 12th perihelion, and work begins on a new dish at the European Space Agency's tracking station in Western Australia. All that and more still to come on SpaceTime. NASA's Parker Solar Probe has just completed its 12th perihelion, flying down to within 8.5 million kilometres of the Sun's surface. The close encounter saw the spacecraft swoop through the blistering solar atmosphere at over 586,860 kilometres an hour, fast enough to cover the distance between Los Angeles and London in under a minute. The milestone also marked the midway point of the mission's 12th solar encounter, which began on May the 27th. Mission managers say the 685-kilogram spacecraft entered the encounter in good shape, with all systems operating nominally. Launched in 2018, the Parker Solar Probe is on an unprecedented mission to study the Sun up close. It'll trace the flow of energy that heats the Sun's outer atmosphere, the corona, shed light on the source of the solar wind, the constant flow of charged particles escaping from the Sun and filling the solar system, and explore how solar energetic particles, which can make the 150 million kilometre journey to the Earth in under an hour, are transported and accelerated. The idea for the mission goes back to 1958, but it's taken until now for humans to have the technology to undertake such a flight. This report from NASA TV.
The Sun. It's our solar system's engine, and the only star in the sky that gets our attention every day. But up close, it's unlike anything we can see from Earth. It's ferocious, a writhing mass of nuclear chaos, tangled magnetic lines, and a constant wind with inconceivably high temperatures and speeds close to 1,000,000 miles an hour. Over the years, NASA has sent probes all over the solar system, but never to the Sun. Parker Solar Probe, humanity's first mission assigned to touch the Sun. It will fly to within 4 million miles of the Sun's surface, confronting brutal radiation and temperatures that can reach 1 million degrees Fahrenheit. Parker Solar Probe has been prepped to fly right through that unforgiving atmosphere. It's a rough journey. Typically, if you want to head out into the solar system, you've got to merge with orbital traffic. But if you want to head out into the center of the solar system, you've got to run the other way. And it takes a lot of energy. Once it arrives, the spacecraft has got to take the heat. Bathed in radiation as it swoops close, Parker Solar Probe will use an advanced carbon-carbon composite heat shield to protect its delicate instruments. The spacecraft's thermal regulation system will use just a single gallon of ordinary water, H2O, to collect and then dissipate heat, just like a car radiator. It will fly into the corona, the super hot region of gas and plasma surrounding the sun. There's hardly a there, as high energy particles fly outward like streamers. But, and this is another weird thing about the sun, the corona is hotter than the surface of the star itself. We have a few good theories about this, but we're really not sure why. There's some process in the atmosphere that keeps heating it up the further it gets from the core. And Parker Solar Probe is really gonna try and figure it out. The corona also propels the solar wind out into space at incredible speeds, way beyond the orbit of Pluto. No one knows for sure what accelerates it so far, so fast. Parker Solar Probe is going to fly right through the origin of this wind, right to where it starts, to figure out how the whole system works. We can't see those processes from Earth, or even from space. Parker Solar Probe is our first direct encounter with a star. Our sun is the only star we can visit, which means this mission will gather important information about how stars work everywhere. That's information we can only get by going straight to the source.
Just months after its launch, Parker Solar Probe became the closest man-made object to the sun, passing within 42.72 million kilometres from the sun's surface. More from NASA TV.
NASA's Parker Solar Probe is a mission to explore the sun. How can it do that? Why won't the spacecraft melt? Excellent questions. You can't face off with the sun without packing the right gear. This is why Solar Probe is equipped with a white shield that reflects heat off the front and keeps things cool in the back.
The heat shield is made out of a couple of different materials. One is carbon-carbon, which is a lot like the graphite epoxy you might see in your golf clubs or your tennis racket, but it's just been superheated. The inside is a carbon foam, which is just another form of carbon and is actually about 97% air. It's a very lightweight way of making a very strong structure.
Nobody likes a needy explorer. Solar Probe can take care of itself, thank you very much. And that's because it has autonomy software that will keep its instruments safe and cool behind the heat shield.
We're too far away to joystick it into place, so it basically has to always be sensing whether or not the heat shield is in the right position and correct itself if it isn't. There are these things called solar limb sensors that are just poking out at the very edge of the shadow. And if those get illuminated, the spacecraft knows, oh, I'm going the wrong direction, and can actually right itself.
It's important to stay hydrated in the sun, even for a spacecraft. Solar Probe circulates water to keep the solar cells from overheating. It stays cool and keeps power.
So basically, water flows behind the solar rays and into the radiators. And so the water warms up when it's behind the solar cells and then cools down up at the radiators. And so that heat transfer is happening a lot like the veins in your body.
Heat is not the same as temperature. Temperature is a measurement, but heat is energy transfer. This matters because Solar Probe will be visiting the sun's outer layer, the corona. Like all stars, the sun is made of plasma. How tightly packed that plasma is depends on the layer. While the sun's corona has a very high temperature, the plasma particles are fairly spread out. So even though the temperature in the corona is 2 to 3 million degrees Fahrenheit, the heat around the spacecraft is manageable.
The corona and where we're going is actually not that dense at all. There are only a couple particles. And so when we think about it, those are very hot, but we're not touching a lot of them. It's the kind of like when you put your hand into an oven, and the oven might be at 400 or 500 degrees Fahrenheit, but your hand isn't at 400 or 500 degrees Fahrenheit.
In December 2021, NASA announced that Parker Solar Probe had achieved its cornerstone objective, making the first measurements from within the atmosphere of a star. When Parker Solar Probe entered the solar atmosphere, it made the first ever crossing of what's known as the Alpha critical surface, the boundary where solar material anchored in the sun first escapes and becomes the solar wind. Until this crossing, no one knew what this boundary would look like. During its first pass close enough to cross this boundary, Parker Solar Probe passed into and out of the corona several times. This revealed key information about the boundary's shape, showing that the alpha critical surface wasn't shaped like a smooth ball. Instead, it has spikes and valleys that wrinkle the surface. Instruments aboard the spacecraft established that the wrinkles were due to coronal streamers, giant plumes of solar material rising up through the sun's atmosphere. Streamers have long been observed by sun-watching spacecraft near Earth, but never before measured directly. Parker also confirmed the existence of a dust-free area close to the sun. Dust is just about everywhere in the solar system. It's the remnants of collisions that formed planets, asteroids, comets, and other celestial bodies billions of years ago. Almost a century ago, astronomer Henry Norris Russell predicted there should be a region around the sun where dust particles get so hot they sublimate and thus disappear, creating a dust-free zone. People have been looking for evidence of this sublimation zone for decades now, but there's never been any consistent evidence of its existence. Until now. Parker's made the first direct detection of dust depletion close to the sun, observing the light reflected from dust dimming some 13.2 million kilometres out from the solar surface. Models based on these results suggested the dust-free zone should exist starting at about 3.5 million kilometres out from the sun. When Parker's solar probe sent back the first observations of its voyage to the sun, scientists found their magnetic field instruments spiked with what became known as switchbacks. Rapid flips in the sun's magnetic field that reversed direction like a zigzagging mountain road. During Parker Solar Probe's sixth flyby of the sun, it found these switchbacks aligned with magnetic funnels in the sun's surface. These funnels emerge from between structures known as supergranules, giant bubbles on the sun in which hot plasma from the solar interior rises up, spreads out across the surface, cools, and then sinks back down again. The magnetic geometry of these regions suggests that magnetic reconnection powers the solar wind. While the new findings locate where the switchbacks are made, the question of how they are formed is still a matter of active research. Parker's also measured solar energetic particles escaping from the sun. Measured near Earth, these solar energetic particle events are relatively rare and hard to predict. But detecting them close to the sun has changed just about everything scientists knew about these speedy particles. The new data suggests they're much more common than expected, and they contain a far wider range of different types of particles than expected. And their paths from the sun are nowhere near as direct as previously thought. They can be disrupted by the switchbacks, and at times follow a path twice as long as expected. By measuring these events close to the sun, scientists are detecting events so small that all trace of them is lost before they reach the Earth. This is helping researchers develop a fuller picture of where they come from and how they're accelerated away from the sun. This report from NASA TV.
After spending a few years spiraling closer to our star, the spacecraft has finally arrived.
It's amazing. Parker Solar Probe is touching the sun.
This is Noor Rawafi, the project scientist of the mission. He has been waiting for this moment since the beginning of his career.
This is a dream come true. One of the major goals for the Parker Solar Probe mission is to fly through the solar corona, and we are doing that now.
So what does it mean to touch the sun? To answer that, we need to look at the sun's structure. Unlike Earth, the sun doesn't have a solid surface. It's a giant ball of hot plasma that's held together by its own gravity. Solar material flows out from the surface, but around the sun, it's bound by the sun's gravity and magnetic field. This material forms the sun's atmosphere, the corona. Eventually, some of this hot and fast solar material escapes the pull of the sun and gushes out into space as solar wind. The boundary that marks the edge of the sun's atmosphere is known as the alphane critical surface. We didn't know exactly where this boundary was, but for the first time in history, a spacecraft has crossed it. Parker Solar Probe ventured into the corona, touching solar material still bound to the sun. The wispy corona is too faint to see most of the time, but it's revealed during total solar eclipses. For centuries, we've been studying the sun's atmosphere during eclipses because it's important for understanding how our star influences life in the solar system. But much about the corona remains a mystery.
Two of the most challenging scientific mysteries in astrophysics occur in a region that we call solar corona.
The first mystery is about the temperature. The corona is about 300 times hotter than the photosphere,
the visible surface of the sun below. Secondly, there's a constant stream of particles flowing from the sun known as the solar wind. It accelerates up to millions of miles per hour out of the corona, and we don't know how. Solar wind can disrupt our satellites and technology. To better protect them, we need to go where the solar wind starts, in the corona. So heading there has been a key goal of NASA's for a while. We first proposed the idea of sending a spacecraft to the sun in 1958. We didn't have the technology to withstand the journey until the 2000s. Since its launch in 2018, Parker has been heading towards our star. Then, in April 2021, during Parker's 8th orbit around the sun, the spacecraft was around 20 solar radii, or 8 million miles from the sun's surface, when it crossed into the corona.
This is a huge milestone. It took us over 6 decades to come to this point.
As Parker entered the corona, its whisper instrument took the images. Streams of plasma surrounded the spacecraft, and Parker's other instruments detected that the magnetic conditions had changed. Outside the corona, solar wind gushes out, pushing solar material away at high speeds so that it can't return back to the sun's surface. Inside the corona, the sun's magnetic field becomes much stronger. Solar material is slower and tethered to the sun. Instead of a smooth divide, Parker found that the boundary between these two sides is wrinkly. These bumpy ridges are created from huge flows of plasma traveling out of the corona. Scientists are not sure why this happens, but as Parker gets closer, we're finding more clues. Before entering the corona, Parker had seen kinks in the solar wind where it would momentarily double back on itself. Scientists called these features in the solar wind switchbacks, but no one knew how or where they formed. In 2021, the spacecraft finally tracked switchbacks to one of their origins. As Parker got even closer to the sun, it detected bursts of switchbacks. Scientists traced these bursts all the way to the visible surface of the sun. As heat rises beneath, convection cells churn and create funnels of magnetic energy above the surface. Scientists found that switchbacks form inside these funnels before rising into the corona and beyond. This is only one piece of the switchbacks puzzle, though. Exactly how they form is still unknown. Over the next few years, Parker will keep looking for clues as it explores our sun, the only star we can study up close. The sun is also the only star known to support life, so understanding it is critical as we search for life beyond our solar system.
That will link directly into the question, are we alone in this universe? And that is one of the biggest questions for humanity to answer.
This is SpaceTime. Still to come, work begins on a new dish at the European Space Agency's tracking station in Western Australia. And later in the science report, tropical coral reefs now threatening to invade Sydney Harbour. All that and more still to come on SpaceTime. Construction's now underway on the European Space Agency's latest deep space communications antenna in Western Australia. The new 35-metre dish, which is being partly financed by the Australian Space Agency, is being built at ESA's existing new Norcia tracking station, 140 kilometres north of Perth. The facility already has a 35-metre main dish, as well as a 4.5-metre acquisition dish. Once completed, the second main dish will provide increased capacity for ESA's Deep Space Communications Network S-Track, which also includes 35-metre dishes in Spain and Argentina and smaller dishes in Sweden, Belgium, the Azores, French Guiana and Kenya. The antennas in ESA's Deep Space Network are operated by ESOC, the main control centre in Darmstadt, Germany. They provide constant communications with ESA missions orbiting the Earth and in deep space. Australia's National Science Agency, the CSIRO, has been ESA's local partner for operations and maintenance of the new Norcia facility since 2019 and will likewise be responsible for this additional new antenna. This is SpaceTime. that's the show for now. SpaceTime is available every Monday, Wednesday, and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favorite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details. And if you want more SpaceTime, please check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as heaps of images, news stories, loads of videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTimeWithStuartGary on Instagram, through our SpaceTime YouTube channel, and on Facebook, just go to facebook.com/SpaceTime with Stuart Gary. And SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.